This video gives you the full working for calculating the pH of a weak acid. We're going to follow through these 8 steps. First up, I'll explain the assumptions that we need to make at step 4. You will not need to write these out every time you do a question, but it's important you understand them. One of the assumptions we make is that the hydronium ion concentration is equal to the weak acid's conjugate base. So when we look at the equation for a weak acid, which is one just here, we're talking about the concentration of these hydroniums here on the right hand side. Their concentration will be the same as the concentration of the OBR minus in this instance. What we're doing is we're assuming no hydronium comes from the dissociation of water itself, because water does self-ionize. We're assuming that all the hydroniums we're dealing with are the ones that are from the proton being donated from the HOBR. The other assumption that we make is that the concentration of the weak acid is the starting concentration that they give you in the question remains that concentration. So we're assuming that there's actually no dissociation at all. Now that's not entirely correct, but the dissociation is so minimal we can ignore it. Like I say, you won't need to write these assumptions out, but if we look at this equation and the question, when we look at the first assumption, we're going to assume that our hydronium concentration produced is the same as the OBR minus, in this instance the conjugate base. Okay, their two values will be equal. And the other assumption is that the weak acid, they tell us that it is 1.5 moles per litre in this question. So we're going to assume that that is the concentration of the HOBR of the acid, even though it's dissociated just a fraction. So it would have been a little bit less. Right, let's continue. So step 1 is write yourself out the equation, because step 2 is to write out the Ka expression. So again, it's products over reactants. You've got your conjugate base, OBR minus, times your hydroniums, and then that's going to be divided by your acid concentration. Okay. From there, we need step 3, and that is to determine your Ka value. Now this question, they've given the Ka to us. Sometimes you're going to get given the pKa, so you'd need to use the inverse log of your pKa to get that Ka value. Moving along, so the assumptions are that the H3O plus is equal to the OBR minus, and our acid concentration at equilibrium is still going to be 1.50 moles per litre. From there we're into step 5, which is to substitute in the data you've got and your assumptions. So you'll notice that what I'm doing here is I'm replacing the OBR minus with a hydronium, and I'm replacing the HOBR with the original concentration of the acid. Now what I can do is write that and replace the Ka value as well. So in the question they told us the Ka was 2.40 times 10 to the negative 9. So what we've got here is the substitution into the Ka expression. Notice through the assumption we've enabled ourselves to remove one of the unknowns by replacing the OBR minus by a hydronium. So that's where you get your hydronium squared from. Next step is to rearrange this expression so that it is hydroniums are the subject. Notice it was hydronium squared, and so to find one hydronium, that's why we've taken the square root of it, and then it's your Ka times your 1.5, because you need to put that on the other side of the equal sign. From here, once you've got it rearranged to find hydroniums, you're just doing the maths. So plug those two numbers in your calculator and find the square root, and you'll find the hydronium concentration is 6 times 10 to the minus 5. From there, what we need to do is find the pH like you would if it was a strong acid now. So you put your hydronium concentration into the negative log of hydroniums and you get your final answer. And the question's done. So you might have felt that there was a lot of steps in this process, but you'll find that the question tends to lead you through writing out the equation and the Ka expression as a standard practice. Whether you need to determine the Ka from pKa, again, you're just going to have to read the question and take it in your stride. The assumptions, you do not need to write them out, but it's important you understand them so that you know what you're doing for step 5, because step 5 is really where you're sort of on your own and having to work out what to do. And then it's a nice case of just rearrange to find the hydronium, actually get the hydronium value, and then plug it into the good old pH calculation that we did for strong acids, and the job is done. In the SciPad, they have sort of streamlined this and cut it right down. So they start with the Ka expression, just as we did. They've made the assumptions in this little voice box here, and you'll notice they're the same assumptions. The hydroniums are equal to the conjugate base concentrations, and that's allowed them to replace that A- with hydronium, and that's why it's squared. And you'll see that they've also got their, actually I can't see that they have, but the HA concentration at equilibrium, we just use the original concentration. And so what some students choose to do is just memorize this box. It is not given to you on your resource sheet in the exam. You will need to memorize it. So for weak acids, it's the hydronium concentration is always equal to the square root of your Ka times your acid concentration. Okay, I'll stop the video there. Keep it short and sweet. Thank you.